Right. Thanks for playing that. Welcome to all the participants to this TCS Research Cafe. So, I'm sure all of you are curious what this Research Cafe is all about. We have been getting questions on that. Before proceeding, I can be heard, right? Am I heard?
Yes,
Yes, sir,
Sanjay.
you're audible.
Okay, all right. So I have to give you a little bit of a history. So this is supposed to be an informal discussion, really, in a very informal session. So you will forgive me for just going a little bit over the time. So the way it originally started was researchers from TCS Research would go to campuses physically, meet the students and just discuss over a cup of coffee. And that's how the name TCS Research Cafe came about. And this format, was tried out at various places. The intention was just to interact with students, let students know about what work TCS Research does, and students would ask questions like, "What's it like to work in TCS Research?" and so on. But of course, this is the closest we can come to that in the current times. This is what it is. It's just an informal discussion with TCS researchers. And to take the discussion forward, I'm very happy that we have with us my two young colleagues, Dr. Harshad Khadilkar and Dr. Supratim Ghosh. So Harshad is a senior scientist at TCS Research. He also holds a visiting associate professor's position at IIT Bombay, and is also associated with the Robert Bosch Center for Decision Sciences and Artificial Intelligence at IIT Madras. So his interests lie in control algorithms for industrial problems like supply chains, transportation systems, and energy networks. He has a BTech from IIT Bombay and an MS and PhD from MIT. And Supratim is a scientist with TCS Research. He got his MS and PhD in electrical engineering and an MA in mathematics from the Penn State University. After that, he also had postdoctoral stints at the Singapore University of Technology and Design and the University of Michigan at Ann Arbor. He and his team apply essentially control and optimization to problems in supply chains and robotics. So Harshad is going to just walk us through, give us an overview of what kind of research goes on at TCS Research, and then the floor will be open for discussions. Yeah, over to you, Harshad.
Thank you, Sanjay. So mic check and the just checking that you can see the slide that I'm projecting.
Yes, we can see the slide and we can hear you.
Okay, excellent. So welcome everybody. Like Sanjay said, this is going to be an informal session. So once we are done with this slide deck, which should take no more than 20 minutes, you should feel free to unmute yourself and ask any questions you have about what work we do at TCS Research, as well as what it's like to work here. How do we go about with the recruitment process, anything that you can think of. So we'll jump straight into it. Roughly speaking, TCS research can be divided into two parts, which are called TCS research areas and research programs. Now, obviously, this is going to be a highly simplified view of what we actually do. So there is a lot more nuance and complexity to the kind of roles that people perform at TCS Research, but this is a good way of showing it in one slide. So on the research area side, we have more foundational kind of research. We have a very wide variety of topics that we cover in our various research areas, including the ones you would expect, like software systems, computing systems, and so on. But we also have a very large focus on data and decision sciences. So coincidentally, all three of us, Sanjay, Supratim, and me, are associated with the data and decision sciences research area. We also have a closely related research area working specifically on deep learning and AI. And we have a lot of other research areas as well, including cybersecurity and physical sciences, life sciences, and media and advertising, which are things you may not have expected TCS to be looking at, but we are putting in a lot of effort in these areas as well. On the other side are research programs, which are focused more on taking the work that we do in research areas and putting it closer to practice. So working closely with business units to deploy some of the algorithms that we develop on the research area side. And these, closely reflect what happens in the research area. So the cybersecurity and privacy research area is reflected in the research program side by data protection and privacy and so on. Right? So you can connect the dots between most of these research areas and research programs. So Supratim, my colleague, is also associated partly with the smart machines and autonomous infrastructure research program. Supratim, do you want to quickly talk about what happens there?
Yeah, thanks, Harshad. Am I audible?
Yes.
Yeah, so actually, one cool thing about TCS is that there are absolutely no boundaries. Okay, so as Harshad said, primarily my affiliation is towards data and decision sciences, but I also collaborate heavily with the smart machines and autonomous infrastructure. So we build robots, for practical purposes. Especially, so recently we built something called Pal Picker. It is it's an autonomous mobile robot, or AMR, which moves on the factory floors, picks up pallets, and then loads onto trucks for transportation. That resulted in a wide variety of patents and publications. In addition, currently the Smart Missions group is looking at exoskeletons for further research, and we also have a TIH, or Technology Innovation Hub, with IIT Delhi, where we are focused on robotics research. Over to you, Harshad.
Thanks, Supratim. So Supratim briefly mentioned the fact that we have collaborations with other universities and startups. So this is a more detailed look at what we are doing. On the left-hand side, you have the foundational research in maths, physical sciences, behavioral sciences, and so on. But we also have this very large extended ecosystem, which covers people in academia. So we collaborate actively with professors and other academic groups. We collaborate with startups in a kind of three-way agreement with some of our customers, right? So if a startup has a solution which a customer finds very relevant, then TCS can act as a go-between to guarantee the fact that whatever is delivered will work. It will work on top of the customer's IT systems and so on. And we also work with venture capitalists and other alliance partners. Similarly, the work that we do spans everything from industrial applications to societal applications and digital technologies. And we are talking about a very large amount of investment, right? So as of 31st March 2021, you will see at that bottom row that we have more than 6,000 associated research inventors and innovators, over 1,000 patents granted, to more than 240 publications, a large number of which are in top tier A-star type of conferences, many innovation labs, academic partners, and so on. And key number on the right is about $260 million worth of investment. Right? So it is a very large amount of capital, both in terms of human capital and money that is being poured into all of these research areas and research programs. So we also briefly, as we talked about, we have a large co-innovation network which spans most of the continents. So we have collaborations with most of the IITs and ISCs and large colleges in India. I personally work a lot with IIT Bombay and IIT Madras because of my affiliations. But we also work a lot with people in the UK and Europe, and also with North American universities, including places like Harvard, Duke, Yale, etc. So in fact, Supratim has been working with some people in Yale already, and I'll ask him to maybe cover that in a minute.
Yeah, so I am working with a faculty member at Yale on submodular optimization. Essentially, it's a concept which can be applied in cases where deep reinforcement learning and other techniques do not provide guaranteed optimization bounds. In addition, I'm also working with a faculty member at Imperial College London, which actually would interest this community more. So that involves the control of adversarial multi-gen networks that we are trying to. So we are trying to achieve, like how can we essentially disrupt a multi-gen network so that we can guarantee control over its communication, so that it follows what we are trying to do. In addition, we also have collaborations with ISER Bhopal, IIT Bombay, and other institutes that we'll probably talk about in details later.
Sure, thanks. So what does all this result in? There are two types of impact we are broadly interested in. One obviously is what is the business value of what we are doing, and whether all the research we are doing is more blue sky research, castles in the air kind of stuff, or is it more practical? And the answer is that we are focused mainly on research that is practical and that can go into practice. Right. So on this slide, we have just 7 examples of things that were born in research and incubated here and now are full-fledged TCS products. Right? So Ignio is probably one of the most famous products that we have, which automates your IT support. More or less all of your system patches, antivirus, etc., so resolving IT tickets, all of that is done automatically in the program itself, so that you don't have to rely too much on human intervention. Teacup is an IoT platform which is specifically focused on the growth of Internet of Everything. Right? So when you have a very large amount of data coming from very diverse heterogeneous sources, how do you put them all together into a single platform so that you can actually get some insights out of that data? And otherwise, it just remains hazy data which nobody can really work with. Then Knadia is something we have done for conversational systems, and in fact, a lot of Knadia's work is already deployed in TCS systems itself. So most of our HR or other policy kind of questions are answered directly by this chatbot, which has been spawned from Knadia. Energy management is another thing that was developed in TCS Research and is actually operational in TCS as a whole. So this focuses on managing the energy in all of our buildings. I think it covers around 60 or 70 buildings around India in a single control room, which is then monitoring all of the energy consumption in these buildings and finding ways of making them more efficient. Optumera is a retail product. It focuses on everything from digital merchandising, which is in the storefront, all the way up to e-commerce and supply chain. And we have worked on many different AI-based algorithms for making sure that these systems work as efficiently as possible. Drones, Supratim mentioned the development of actual physical robots. This is another work that is also focused on physical robots. So we don't build the drones. What we do is add image processing and machine learning algorithms on top of drones to make sure that that data is processed, perhaps on the edge, perhaps on the node, but it's giving you actionable insights as quickly and efficiently as possible. And digital twin is something that has been growing a lot. I'm sure you have heard about digital twins already, which is essentially a very high fidelity simulation of anything from industrial systems to full enterprises. And what can we do about answering what if or if what kind of questions based on these solutions. So these 7 things are things that have already gone into business and are generating revenue for TCS. But
Arshad,
yes,
sorry to interrupt you. So I think it would be worth mentioning that our TCS IISc collaborative team participate in the MBZIRC challenge, where they had to perform various tasks using drones. And I think they were ranked pretty high, I think in the top 5 or 7
Yes.
worldwide.
Correct. Thanks for that. Right. Yeah, and I mean, being TCS part of the Tata Group, we are not focused purely on business impact. We also care about the impact we have on society, how to be good neighbors. And these are some of the things that have come out of TCS research and have made the real societal impact, right? So the first of these is the Social Enterprise Education Lab, or SEED, which encourages entrepreneurship and job creation around the world. Some of these labs are also based in India, and they help launch startups, or if you already have a startup, they help you grow, scale very quickly. Digital farming is another thing that has come out of TCS research. In case you have heard of an app called M-Krishi, it helps India's farmers ask questions or personalized solutions based on IoT devices, and it's already affected more than 2 million farmers. Uh, incubation labs, our incubation labs have also worked a lot on accessibility. So how can we get VR and AI into the real world and help people with neuromuscular disabilities? Access Infinity is another initiative that was also about accessibility and bringing education closer to the masses. So there is a lot of downloadable books on this platform, more than 6.7 lakhs worth, which are now available for free download. Sustainability is another big challenge, and we have been working on many different fronts on this, but this is just one example where we have done this in Singapore, where we have created a challenge for budding tech students and to come up with ideas about how to bring about a sustainable future. And finally, we sponsor a lot of TCS research scholars all over India in various programs. And I hope some of you are on this call as well. So these are some examples of the breadth of things we do even on a single topic. Right? So if you look at COVID-19 as a problem or a challenge, there are many different ways in which we have tackled the various challenges posed by the pandemic. And these are just 5 of them, but I believe there were at least 30 or 32 which had become fairly large projects in their own right. And these span the whole spectrum of things you can do around COVID, right? So there is, on the right hand side, it's directly tackling the medical side of it. So can we generate drug candidate molecules using simulations, in silico evaluation of potential candidates? And can we use AI to find out which molecules are more promising and which ones are less promising, so that you have to do fewer clinical trials to find the right drugs? Then you have, can you analyze radiology images, X-rays, CT scans to determine how much COVID has spread in somebody's lungs, and other, detect any other pathologies that can be seen in X-rays or CT scans. We have looked at epidemiological graph modeling. So can we model how the disease will spread given the amount of people moving around and the strength of lockdown and so on? And not just model how it is spreading, but also optimize lockdown strategies, right? So I'll cover this in the next slide, so we'll go into details at that time. And finally, we have work on conversational agents and text mining. So all of the work I showed you earlier on Knadia and chatbots, it can be repurposed to answer questions about COVID, right? So what should I do in case I'm feeling X or Y symptoms? Do I have COVID? Should I get tested? Questions like that. Right. So there's the whole gamut from actual biological modeling all the way up to control theory. And this is an example that was on the previous slide. So if we want to optimize lockdown strategies and make it quantitatively justifiable, the problem we had, I think, in our country and in most places in the world was that lockdown strategies were based mostly on gut feel. And it becomes therefore a bone of contention whether you should or should not lock down. So what we were trying to see was, can we actually make it more quantitatively justifiable by modeling it as a population flow model, by including the best information we have about the disease and how it progresses, for individual patients, from susceptible state to exposed to symptomatic or asymptomatic and so on. And then can we develop a reinforcement learning based agent on top of this that watches what is happening around the country and decides whether any given district should be locked down or kept open for the next week. And this optimization is done based on a user tuned parameter about how much importance you want to give healthcare cost versus economic cost. And so this becomes slightly more, quantitatively justifiable as to why you should lock down a district or you shouldn't lock down a district for a given day. And I should mention that this wasn't work that was done purely in TCS, but it was with my colleagues in Microsoft Research as well. And it's not just serious things that we do. So we also do a lot of fun stuff, including taking part in competitions in some of the best conferences in the world. So NeurIPS is a competition which comes with a lot of is a conference that comes with a lot of competitions every year, and we have participated in it regularly. So on the left hand side, we have a game called Pommer Man, where the idea is to have these two teammates which are sitting across the board from each other work together to defeat the other two people who are part of the opposing team by placing bombs around them and essentially killing them. Right. So this is a fun thing when we are talking about the competition itself, but it teaches a lot of serious stuff about how to work in cooperative and adversarial environments and how to use partial observability and still work around that using reinforcement learning. Right. Similarly, we have work in the Flatwell environment, which I'll request Supratim to describe.
So this is actually a two-dimensional environment capturing a dense railway network. Here, the objective is to efficiently schedule and plan routes for multiple trains so that they reach from their point of origin to their destinations in the shortest amount of time. And so we have multiple cities within a single network, and we have like stations where you have branch lines through which a train can go, or otherwise the train has to go like follow a path in a straight line when it is on a single track. So it basically is let's say a two-dimensional representation of a dense three-dimensional network. We did pretty well in this challenge. We were the 4th, 5th, and 7th ranked teams among around 700 participants worldwide. I think this took place last year with with the NeurIPS conference.
Thanks, Supratim. And finally, it's not just applications that we are looking at in TCS research. We are looking at some very fundamental questions in the control and reinforcement learning areas as well. So these are just 3 examples of papers that my group has published in the last year or so, looking at fundamental questions in the RL, including how do we improve sample efficiency, how do we improve robustness, when the environment has variable size problems, every instance has a variable size and so on. Right. So on the left hand side, you have a reward shaping approach, which we have shown converges in expectation to the optimal policy. So even though you're doing reward shaping, you're not changing the optimal policy that you converge to, but it does so in a much faster rate than what typical baseline algorithms do. And the way it does this is by looking not just at results or rewards within an episode, but the history of rewards across episodes as well, and gives itself a feedback signal essentially as to whether it is improving or not. Right. So this helps us converge a lot faster using a lot fewer samples. In the center, you have a problem that started with our work in supply chain, where lead times are a big issue. So when you order some amount of goods from a vendor, or when a store orders goods from a warehouse, there is always some time gap before the goods are actually delivered. And so this delay, which we can think of as control delay in the control context, can really destabilize the system, just as it does any control system. And so we have come up with a reinforcement learning modification called delay resolved Dqm, which is, solves this delay explicitly, and we have shown that you can significantly improve the rate of convergence as again. And finally, we are also looking at how do we get better latent representations of a given state in a deep reinforcement learning approach by not just having the network, the deep neural network predict the policy, the next action, and the value of the current action, but also can you predict the next state, so that you're forcing the latent representation to represent things more robustly in some sense, because you're learning what is happening in the domain and not just focusing on the rewards you're getting. So these are just three examples of papers we published last year in AMAS, CIKM, and IJCNN respectively. This is another work which is actually coming up in next year's AAAI. And this is also a more fundamental question. It's about finite time conversions, but focused on deep learning applications. So there are very standard optimizers currently, such as stochastic gradient descent or ADAM, that everybody uses really without thinking. Okay, but one of the things that happens with these optimizers is as you get close to the optimal point, as you get close to convergence in your neural network, the gradients become very, very shallow. And so the rate of convergence is very slow. And so we were looking at how can we make sure that the rate of convergence is faster. In essence, we have finite time convergence guarantees by speeding up the rate of convergence when you get close to optimality. And so this work is coming up in AAAI next year, and it was led by my teammate Mayank Baranwal in collaboration with professors from IIT Kharagpur. Yeah, and this is work by Supratim. So Supratim?
Yeah, hi. So actually, while we do a lot of work on using RL in deep reinforcement learning and other techniques, we also want to employ standard, traditional techniques such as control theory and games and optimization to real world problems. So I'm presenting a snapshot of the work that we did, that we have this year, published last year. So the first work is actually three-dimensional bin packing algorithm, where we employed standard optimization techniques such as integer linear programming and heuristic and meta heuristics, and we were able to improve the performance of the system over traditional techniques. We actually developed a system where we had a linear increase in computational time with respect to increasing information that we are trying to achieve, and this is actually published in this conference itself. We had a talk about this in today morning. The second work deals with routing of vehicles using deep reinforcement learning. Now, vehicle routing is a problem which has been dealt pretty heavily in the last 40-50 years or so. However, most of the solutions that we have using either meta heuristics or optimization, they do not scale well beyond a certain number of customers. Now, as you will appreciate, with the pandemic and other trends in the outside world, the e-commerce has become a pretty valuable commodity in our life, and therefore the number of customers that these e-commerce organizations need to serve typically number in thousands. To solve vehicle routing at that scale, we have to look beyond traditional approaches, and that's where deep reinforcement learning comes in. However, we also again do not want to get out of the meta heuristic framework completely. So we combine heuristics and deep reinforcement learning to solve NPR problems like vehicle routing. Then finally, on the last work that I'm trying to describe here is optimization of a sorting center process. Here we are trying to create a feedback between traditional optimization and simulation. So we all do simulation when we are trying to see how a process will enact in real life, right? However, whenever the simulation environment that we're talking about is a faithful representation of what the physical system will actually look like, that simulation environment is called a digital twin. So here in this case, what we did was we created an optimization simulation feedback forward pipeline, where optimization will send information to digital twin. Then the digital twin will give feedback to the optimization framework, and overall the process of allocating parcels to various shoots or various outlets within the sorting center will be optimized. So these papers were presented, were published in ICC, COTS, COMAD, and Winter Simulation. Can we go to the next? Yeah. So, so the previous slide actually talked about applications. So mostly, as you saw, applications dealt with supply chain, retail, and sorting type of environments. Here, I'm trying to talk about the fundamental work that we are doing, that I am doing. So the first paper is with a colleague of mine from Imperial College London and IIT Bombay. So here we are trying to generate adaptive controllers for semi-linear infinite dimensional systems. So in these systems, so we are looking at systems where we do not have what we call as coercivity, a property called coercivity of the Lyapunov operator, and that makes the synthesis of optimal controllers very challenging. So we showed weaker bounds on observer error and tracking error than what are available in the literature, and this paper was published in CDC this year. Then finally, we are also, this is the work that I mentioned at the beginning of the presentation. We are working on securing multi-agent networks. So we are looking at, let's say, we are looking at multi-agent networks in an adversarial setting. So let's say we have a network with a certain objective that is trying to harm us, and we have our own network that will try to fight with this network so that our objective, or rather our defense, can be fortified. So this kind of work, so we are looking at both theoretical and application aspects of this work. So this actually builds on the work that I and Aditya, my colleague, we had done in the past. So we are very close to writing a paper in this context, and I'll be happy to share the paper with this community once that's done. Thanks, Harshad.
Thank you, Supratim. So that is all we wanted to cover in this introduction. So we'll open it up for questions. Sanjay, Supratim, and I are all available to answer them to the best of our abilities.
Hello, can you hear me?
Yes.
Yeah.
Hi, thank you so much for the presentation. One question I had was, this is all great research. Like, what goes behind choosing the problems that you work on? Like, what drives that? Like over time, like how do different research groups go on choosing like different projects?
So there are two extremes from which problems start. One is if in research itself, we find that there are new and upcoming areas which look very promising. In that case, what we do is we start working on these areas in an exploratory sense. And once we get some interesting results, then we connect with the right business units who we think will be able to use that work. So that work goes from research to business. The other model we have is what you could think of as a pull-based model. So if there is a business problem that nobody in the business unit knows how to handle because of mathematical complexity or some other reason, then they'll get in touch with us in research and say, can you help solve this? And so we have these liaison teams which know who is working on what kind of area. And so based on the problem that has come up, they will get in touch with the right teams, and we can then solve a specific problem that has come from the business unit. So it comes from both sides.
Harshad, I would like to add that, in addition to business-based problems that Harshad mentioned, we at TCS Research, Harshad showed in his slides, we also engaged in quite fundamental research. Okay, so we are actually encouraged to pursue fundamental research, say for half of our time. So there are problems which probably business has not recommended to us yet, but we pursue that out of our own interest, and that is encouraged pretty much at a high level.
Right.
Thank you.
Yeah. Anybody else? It could be about the work. It could be about,
this is a pretty informal session,
Yeah.
So just ask about anything, like how TCS Research works, whether there is coffee available, and things like that. Anything.
Like I had another question. Okay, this could be a general question that others might have too. Like the difference between research in industry and academia, and some of you actually work at the intersection of both. So if there are any, like what would be the differences, like working as an academic, doing similar fundamental research and working in TCS research?
So the biggest difference I would say is that in academia, if you think of an interesting problem in a mathematical or algorithmic sense, you can start working on it right away without being too worried about where it can be applied. Okay, and I completely agree that some of the most fundamental results in the last 100 years have come up by people who are not worried about the application of what they were doing. Right. So that is the freedom that academia has and the potential for impact as well. On the industrial research side, we do work on fundamental questions, but we always have in the back of our mind the question of where will this be applied potentially. Okay, it does not have to be applied in the next 6 months or in the next year, but at least in 5 years, there should be a high probability that what we are doing will be absorbed by something in business. So that's the difference, I would say. So Pratim, you have anything to add?
Yeah, I mean, so yeah, I'll just second what you just mentioned. The second thing is, like, in addition, I would like to mention that, so think of yourself as a researcher, right? So what excites you most? Is it writing high impact papers on foundational research? Then probably academia is the place for you. Whereas if you'd like to see your research getting implemented real time in systems that could be eventually used by people and businesses, then I think industrial research is something that you should give a shot.
Right. So for us, fundamental research and fundamental papers are byproduct or icing on the cake, but it's not the cake.
Right.
Yeah, I'll add to that, those comments. So in the academia also, people do foundational or fundamental research, but there's also another aspect to being in academia, which is research consultancy. Right now, research consultancy may not lead to work that is actually deep or fundamental, but it's a way to support the industry outside. So here also, we might sometimes be engaged in activities that are of that nature. We might end up supporting the business in problems which are maybe not that new, or solutions is known to a certain extent. This is perhaps something that one could have turned away from in the academia, because you can choose. In the academia you can say, well, I'll only do foundational research, I'll not do consultancy. I mean, here also to a large extent we have that freedom, but then they are from the same organization, they need some support, so you end up stepping forward to provide it.
Right. And in many cases, we are the recipients of this academic consultancy. So one of the key ways in which we engage with faculty is by having them, or rather by consulting them on some of the work that we are doing.
Yeah, right.
Thank you so much.
Sure.
So I just want to know, is there any internship opportunity for the PhD students at TCS Research?
Yes. So if you see any relevant research areas here, you should feel free to get in touch with any of the three of us, and we can help you find, get in contact with the right team. I believe for PhD internships, we don't have a fixed cycle as such. It is on a case-by-case basis. So if you find a good match with one of the teams, you can do the internship.
In fact, the paper that Harshit showed, which is supposed to appear in AAAI next year, it was written by one of our interns, right, Harshit?
Yes. So he's a student at IIT Kharagpur, and he was interning with us last semester.
Okay, so that CDC paper?
No, the AAAI.
AAAI paper on fixed time conversions of optimizers.
Okay.
So to expand on that question, we do take interns at all levels. And there is I think a well-established channel for internships through the training and placement cells or offices of the various IITs, for example.
Yes, for undergraduates and masters level.
Masters, correct.
Yeah.
Right.
Yeah, and while we are waiting for further questions, the same kind of thing applies to recruitment as well, full-time recruitment. So we are part of the regular cycles for campus placement for undergraduates and graduates up to the master's level. And we in fact hire as TCS Research, not as TCS in general. And for PhD levels, you get in touch with the teams directly, and it is handled on a case-by-case basis. Anybody else? Yeah, go ahead, Srikanth. You don't have to raise your hand. You can just unmute and ask.
Am I audible?
Yes.
Yeah.
Okay, thank you. I'm Dr. Srikanth from Gayatri Vidya Parishad, Visakhapatnam. I have one generic question. We normally teach C language and all, and now we are drifting towards Python and all. And how do you see that? I mean, is it more of we have to go towards these open source kind of platforms and all, or we don't know how the industry requirements are there? But the drift, I mean, 10, 15 years back, the emphasis was on C, C++, and then there was Java. Now we are forced to teach everything in Python, okay? So based on the requirement. So how do you see after 4 or 5 years, do you think we'll end up with another new language?
So it's very hard to predict whether we'll be using Python in 4 or 5 years or not, but I would say that it looks very likely. And for the reason that it has gathered a lot of momentum now from industry as well as from all of the open source libraries that you were talking about. So these days, if you want to do AI or machine learning and you want to do it quickly, the easiest way to get it done is by using Python on top of some libraries, which are open source. So yes, it looks like Python will be the language of choice for the next few years at least. And the fact that it has now gone into production in many companies, including Google, seems to indicate that there is an expectation that it will have high longevity. So Java and C++ will keep going, right? So because apart from machine learning, Python is not a very efficient language to handle your regular web-based applications. So there will be a mix of languages, but for machine learning or control type of applications, probably Python will be the language of choice. And then you can wrap it up and use it in the rest of your web applications through Java most of the time.
But Harshad, would I be right if I were to say that the expectation of the industry from, let's say, an undergraduate programming course is that they pick up programming fundamentals, computational thinking, rather than the specifics of a particular language?
Yes. For teaching, yes. So I would say it's a necessary condition that your fundamentals should be clear, but it is not a sufficient condition right now. At least when we look for it in my team and a few other teams, at least we expect some level of Python proficiency so that you don't spend 6 months picking it up.
Mm-hmm.
But I mean, if you cannot have experience with Python and weak fundamentals, then it's a no-go. So the other way around is probably more acceptable in that case, that your fundamentals are clear, but you have not used Python before, it's still workable.
And we are thinking on lines of the non-computer, non-IT students for whom we teach all these languages, and they are like forced to learn all these along with their regular core engineering of electrical subjects.
It's okay. So if you talk about electrical engineering, for example, you have to learn MATLAB. Okay, because MATLAB is still being used in a lot of control theoretic and other applications. However, I mean, the thing is, like, see, the world is moving. I mean, it's moving at a very fast pace. So right now, you can say machine learning and other techniques, other AI techniques have taken a few of the applications that we are dealing with. In the forthcoming future, you will see that they will take over most of the applications that we are working with. So we have to learn, language. We have to learn Python, and we have to learn how to implement standard machine learning libraries in Python. If we have to, be industry, be beneficial to the industry. Like we have to have a good career in the industry.
Okay, but 20 years back when I was a student, we were only taught MATLAB and C. Now they have to learn LabVIEW, Scilab, MATLAB, and OrCAD, and whatnot. The list is just increasing. It is like the load is exponentially increasing. That is what we have just.
Right now, you can just focus on, let's say, MATLAB for electrical engineering specific applications and Python for computer science specific applications, and that should be sufficient for the industry. You don't have to learn anything else.
Yeah, and while the number of languages is increasing, so is the online support. So in most cases, if you are clear in your head about what logic or algorithm you want to follow, you will find it very easy to search for examples of people who have already implemented what you're thinking of, and they've open source their work, so you can pick and choose. So in some sense, if there is a fundamental skill you need to learn right now, it is to look for the right stuff on Stack Overflow rather than learn any specific language.
Exactly.
Arshad, you might have just given away the industry secret.
Yes.
Thank you.
Sure.
Thanks, Shrikant, for that question.
Again, ask a question, Sanjay. Ramkrishna here.
Oh, yeah.
Okay, general, since it's informal, so one criticism, which also we from the academia face, but also the tech companies which kind of boomed in the 90s and early 2000s, and they are still big. One criticism is that they have not invested heavily in R&D or into some kind of a product across of all companies. And now I see that you kind of list a lot of areas where TCS Research is kind of working on, or maybe supplying ideas to people. So what is kind of the vision, maybe say 5 or 10 years from now of TCS Research, or any of the Indian industrial research scenario, is what I'm saying. So would we expect us to make some of our own products which we consume, or we are still happy outsourcing that thing to somebody else, and companies like TCS or Infosys or others just doing it's largely service oriented industry, right? And I think that's where the major revenue comes even now. And what is therefore also the revenue model for TCS Research? Assuming this is now a new entity, that's what Sanjay was telling me, that you should use TCS logo, not Tata Consultancy Services.
Right. Sanjay, do you want to take that, or do you want me to take it?
Yeah, you can go ahead. That's a good question.
Okay. So Ramkrishna, it's a quite extensive question, so I'll break it up in parts. So first of all, where TCS wants to go, according to what the CEO has published or talked about, and all of the other things that have been aired also, is that we want to move up from being an IT services provider to handling a larger portion of our customers' business. So not just their IT systems, but also their operations, and moving higher up the value chain. And we feel that we are in a very good place. If you think about companies like TCS, Infosys, etc., we are in a very good place because we already know most of our customers inside out, because we have been running their systems for many decades now. Right. So if we want to make use of that data, and we can show that we have the technical maturity to do more than just handle IT systems, there is already a modicum of trust that the customer has in what we do. So we are making inroads into this. Some of the products that I showed in these examples were exactly that. So for example, Optumera, which I have been closely associated with, has now gone into production, and a lot of what we have done in TCS Research has now gone into Optumera, and it's already made inroads into a very large retailers as full projects as well as proof of concept level things, right? And now, we tell them that we'll tell you, in the case of Optumera, we'll tell you how you should set up your store, which product should go where on the shelf, how much you should replenish. So all of the things that people used to do manually are now done automatically, and it's all leveraged by the data that we have been handling for the last 20 years for these people.
So Harshad, I would like to add here.
Yeah.
So in addition to software products, we are also looking at robots, like robotic warehouses. As I mentioned, I can vouch for the fact that we actually developed a robot, a palletizing robot of our own, and that has gone into production. And right now it is being shipped to Europe for a large European client, where we are trying to automate their warehouse, like from a holistic logistics point of view. So as I mentioned, like for example, there is a large team within TCS that is working on robotic research, all the way from drones to logistics to even fundamental problems in robotics such as pathfinding and task allocation. So all of these, so we have multiple and also state of the like the next gen solutions such as telepresence and speech recognition in using robots. So all of these are actually combining they are getting combined together to form products for the next gen for the next generation of robotic warehouses and robotic solutions. So we are, for example, right now we are looking at a problem of how we can use robots and drones for automating large scale sorting centers or large scale deliveries that that are being handled by humans currently. So those kind of research, that kind of research is also being taken up by TCS.
Right.
Yeah, okay. Yeah, having said that, I think we are one of the largest consumers of TCS Ion, which I think is a very successful product.
Right. So Ion is a very successful, like you said, and it's not just a products play. There is going to be a much larger emphasis on products rather than services going forward. That is true, but it's not only products, but it's also higher level of engagement with clients that TCS is looking for, and I'm sure most of our large India-based IT services providers are looking for.
So continuing on that, also continuing with the the paper which your co-author presented this morning on railway timetables and all. If you look at the COVID second wave, there was oxygen shortage, oxygen crisis, and things were all over the media. And one couple of, again, I'm saying everything from media reports. I don't have any first-hand information there. The challenge then those days was not really producing oxygen, because everybody, all plants who could produce oxygen were producing oxygen. But the problem is about logistics. So how could solutions like that come up? Where the requirement, like the time constants are very small. You just need the solution right now. So in those kind of situations, how would including people like us, right, could contribute in those crisis situations? Because I think those times even the court was deciding who will get how much oxygen and so on. So what is a solution from because you have worked on real-time problems for a long time, and what could be your thoughts on those kind of things?
So it's a very difficult question, because just like you, I'm also not a policy maker. But what we did in the company, which I observed, was that we repurposed a lot of the things we were doing for quick use in these cases. So the chatbot was an example. The technology already existed for something else, and it was repurposed for this in an emergency sense. Right. So in that part, research is not so important. It's more about getting it right, getting the solution deployed, and making sure that it is reliably working, even though it is not optimal. But now that the crisis has passed, it's time to take another look at what the actual challenge was, and can we think about it, more deeply and solve it for the future. Because probably things like this are going to happen again, and so we have to be ready in the next pandemic. Fingers crossed it doesn't come up, but no one never knows.
I think also talking of optimality, I think Supritam was talking about submodular optimization and all. We also try to do that and say, look, one algorithm works slightly better than the other, And I think I was talking to some people from the power sector of, optimal placements of PMUs. And the way they work is, okay, look, entire India, you may need, say, 5,000 PMUs. And if your optimization gives 4,845, it doesn't really excite them that much because it's not a big cost advantage that way. So I don't know, this is just my of conversations what I have, and so maybe Supritam can tell a little more of of the kind of optimization problems we solve academically, and what who would be the consumers for them, where if I say, okay, my optimization algorithm or whatever I propose kind of works delta better than somebody else, like, okay, like why would that excite anybody? I mean, okay, I can get a paper, students graduate and all that. What more than that, from the practitioners or the consumers point of view?
So actually, my interest in submodular optimization, it stemmed from the fact that so I was using deep reinforcement learning for optimization since I joined TCS. Okay. But I saw that getting theoretical bounds on how reinforcement learning could work in an unknown scenario is very difficult, nigh impossible to get. And there is a whole field of AI called Extendable AI built around it. Okay, so still AI is not being used in safety critical applications. For example, if you want to, let's say, launch a spacecraft or fly an airplane. For example, if you want to go to Delta Airlines, if you were to go to Delta Airlines tomorrow and say, fine, I'll provide an optimal route for your flight through the wind speeds and changes in atmospheric pressure using a deep reinforcement learning algorithm, they'll turn you back in a moment. Okay. However, now if what those guys are doing are they're again, going back to the traditional approaches like integer linear programs and meta heuristics to solve these problems, and they suffer from the issue of scale. Once the scale becomes high, those algorithms not only, they will provide some result, but they will be far from optimal. So that is where actually submodular optimization kicks in. So I'm sure you are aware that with submodular optimization, one of the beautiful properties of a submodular optimization, a submodular function, is that even a greedy algorithm can give you, I think the bound is 63% of optimal result.
More also sometimes.
Yeah, more in even more in some case. With a simple greedy algorithm, you can get bounds like that. So that is where our motivation stemmed from. So right now, I would say our work is still at a theoretical level. We are trying to still see how, let's say, problems in NTR problems such as routing and scheduling can be they can be reformulated as a submodular optimization problem, and we can get algorithms built around that. Our final goal is to apply these to safety critical applications. There is an area of reinforcement learning called SafeRL built for this kind of applications where your reinforcement learning algorithm has to satisfy certain constraints, but the results there are not very exciting. So we are just exploring how submodular optimization can be used for applications like these. So this actually becomes a motivation. So another aspect, so we do have several papers in literature which talk about how submodular optimization can be used for, let's say, generation of animations, videos, video transfers, even robotic applications such as what is it called? Sensor coverage, for the sensor coverage problem and all. But my interest in this topic actually stemmed from safety critical applications. Does that answer your question?
Sure. Yeah, I'm just I was just curious because of that, because we academically it's of a lot of interest, but I was just curious of from the practice.
So let's say, you know, it's sort of like this way. I want to be able to go to Delta Airlines tomorrow and say, okay, fine, I'm going to give you an algorithm which in the worst case will provide 70% of optimality, but it will be for a large scale. So now say Delta Airlines is flying, let's say 1 million flights a year or something like that. So for that level of optimization, they would happily take a greedy algorithm, a greedy heuristic submodel optimization over integer linear programming any day. That's the final idea that I have over it.
Yeah. Sure. Yeah. Thanks a lot. Maybe I'm taking up too much time. I let the others.
No, sure. Please go ahead. It's an informal session. We can.
No. I want the others to be also informal. At least the younger generation.
Students, yes. Yeah. Do we have any other questions?
Yeah. Last call.
Yeah, the best question will get an internship opportunity or something.
then that would be you, Ramakrishna.
Well, I almost asked if, you know, faculty can apply for a sabbatical at TCS. Oh, actually Sanjay did that, I remember.
Those possibilities are there, definitely.
You started off as a sabbatical on your sabbatical, right?
True. Okay. Of course, that was 12, 13 years ago, which is a very, very long period by corporate standards. So, but yeah, those kind of avenues are still there.
Okay, yeah, good.
Yeah, so like Sanjay said, last call for questions if you have any.
Okay, I a bit of time anyway. So thank you all for attending and listening to what TCS Research does. So hope to see you some days, one of these days on a campus perhaps. So all the best to all of you, and we'll see you tomorrow at the sessions. Bye.
Thank you. Bye.
Thank you. Bye. Ouch.